purpose of this video is essentially just to introduce what groups will be doing as they are completing this, or what you would have to do as an individual to work through this problem. So there's a situation where there are two brothers. The one brother, and I'm going to start at 0. The one brother has a head start of 45 meters, and the other brother does not. And the younger brother has a walking rate of 1 meter per second, and the older brother has a walking rate of 2.5 meters per second. So what I'm going to do is a little different. I don't necessarily have to go up by 1 second. I don't necessarily have to go up by 2 seconds. I can do it. You could do anything you want in this table. So I could say, how far would each person be after, say, 7 seconds? Say, well, it'd be 7. So 7 meters per second. So that would mean 7 more meters, right? Because he's increasing. So 7 more meters from the head start. That'd be 52. Okay, and I try that and I'd be like, well, 7 is going 2.5 meters per second. So that would be 17.5 meters. So I can jump around. I could choose a scale to go up by, but I'm not going to choose a scale of 1 because I want to be able to get up to 40 seconds. So the goal is to at least get 40 seconds in the table. You can go over 40 seconds, but you need to at least have 40 seconds somewhere in your table. Then you're going to try to figure out, okay, well, how can I find, my goal is to figure out where they tie. I want to know where they tie because that's the length of the race, is where they are side by side. So how can I use the table to figure that out? Then I'm going to make a graph. And this graph is pretty open-ended. The only thing that's sure is that time is going to be on the x-axis and distance has to be on the y-axis, but you're going to decide what you want to go up by based on what you have in your table. Now here's the thing. I want 0 to be over here. Okay, so 0 has to be here. And then whatever you go up by, it has to be a scale. So I can't put random numbers down here. I can't be like 7 and then 21 and 45. Like, it has to be a scale. So I can't do that. I have to pick something to go up by. Like, I could go up by 0, I could go up by 5s or 10s or whatever you decide to do. But just make sure that you pick a scale for the time. Then you're going to figure out, well, how can I tell in the graph where they tied? So what's it going to look like in the graph when they tied? That's kind of important. And then what's really important is that you're going to have to write an equation for both boys. So I'm trying to find where that is. So that's number 3, write an equation. So I will tell you that the equation will have, D for distance, okay? I don't know why I did that, I'm sorry. So I'm going to need to have, like a meal. So I'll have D for distance equals, and then how do you calculate as distance? Remember, the other variable is T for time. And the same thing for Henry. So Henry, D for distance equals, and then what do you do to the time to be able to come up with the actual distance for Henry? And we're going to compare those two equations. So if you finish all of that, then you can also look at the different discussion questions here at the bottom, which are really good, or on the next page. They kind of help you to dive deeper into how to understand these graphs and tables and equations. Okay, well, good luck figuring out where Henry and Emil are going to cross. Thanks.